Hello, this is Mr. Stansbury. I'm going to take you through the 17 F notes on where functions meet. Okay. At the end of this, you should be able to say that I can find the intersection points of two polynomial functions. All right, so let's get straight into where polynomials can meet. Okay, so two polynomial functions can have 0, 1, or 2 points of intersection. So if the two graphs cut through each other, we're going to have 2 points of intersection. If they just happen to just touch each other, then you get 1 point of intersection. And if they miss each other altogether, then there's obviously no points of intersection. All right, so let's look at an example. Find the coordinates of the points of intersection of the graphs. And this is example 5 from page 567. And here's our two equations. Okay. Really, the easiest way to do this is to keep using our handy-dandy graphing calculator to figure this out. Okay, so we're going to turn this on. That makes it easiest. Y equals, and we're simply just going to put this equation in for the first y, and then this for the second y, and then graph it. All right, so let's see. We've got x squared minus x minus 18 for the first one, and then we've got x minus 3 for the second one. All right, and then I would imagine the easiest way for to set our window, let's just try zoom standard and see if that gets us a decent enough looking graph. Oops, let's see, there's those. Well, it does give us enough of the graph where we can see where the two intersection points are, so let's just leave it. If you really want to see the bottom of the graph, which we don't need, you can feel free to mess with the window. Just make your y minimum a little bit bigger. Okay, so we need to find these 2 points of intersection. So we're gonna, just like we've been doing before, we're just gonna go into second trace, which is calculate, and we're gonna find the intersection points. Okay, so we push intersect, and again it's asking us for the first curve. X is 0, so it's somewhere, it looks like it's somewhere down here at the bottom. I'm going to find this leftmost one. There we go. Okay, so let's find this intersection first. Push enter. There's the second line. Do we want you to guess? Sure. So one of the intersection points is -3, -6. All right, so we get -3. -6 is one intersection point. And then let's go over and calculate the other intersection. So we simply just cruise on over here until we get close. There it is. Enter, enter, and then guess. And we get 5, 2. Okay, those are the coordinates of the 2 points of intersection for those two graphs. All right, and that's really pretty much all there is to it. Okay, so let's take a look at one other example and then see how you do. Okay, so we're going to try to figure out this one. Y equals x minus 3, and then y equals 4 over x. But of course, before that, we should take a short little video break. All right?
I'm trying to be open-minded as I get older. I'm trying to do things I had never done. Like I recently went to 3 different ballets, and I loved trying to learn how to like those a little bit. 3 different ballets, and they all had like the same story. So I wrote a ballet. I'm gonna submit it. This is the ballet I wrote. This man meets this woman, and he wants to marry her, but he can't marry her because she's already getting ready to marry somebody else. So they all dance around for a couple hours.
All right, anyway. So I put the 2 functions in there, x minus 3 and 4 over x. And again, it should be the same zoom from where it was before, so let's just hit graph. There's the first line, and there's the second line. So it intersects at these 2 spots. So let's see if we can calculate where those 2 spots are. Second, calculate, intersect. Again, we're pretty close there. Enter, enter, and then guess. We're at -1, -4. All right, and then let's calculate the other one. Second, calculate intersection. And then we just cruise up there until we get closer to that one. Enter, enter, and then we're at 4, 1. All right, and that's where these two functions meet. So those are the two spots where the functions are equal to each other. All right, so you should now be able to say I can find the intersection points of two polynomial functions. All right, if you have any questions, please ask. Thanks.